All right, here we go for topic 7.3. This was the quadratic formula, one of my favorites, right? This is on your formula chart, so you don't have to memorize it, or you can sing the lovely song. I'm going to write the formula down on my paper right here so that we have it available to us. I'm going to sing it as I write it, of course. So here we go. X equals negative b plus or minus square root, big long square root, of b squared minus 4ac all over 2a. All right, there's our quadratic formula. Now, in order to use this quadratic formula, it has to be in standard form, set equal to 0, so that you can actually pull out the a, the b, and the c values, okay? If you can't pull out the appropriate a, b's, and c's, well, then we're kind of in trouble from the get-go. Okay, so if you look at number 14 here, clearly he is not set equal to 0, right? We've got to get that negative 59 on the other side. So I'm going to go ahead and rewrite him as x squared plus 16x plus 59. And then I want to make sure I identify my a, b, and c values for myself. So I like to write them down so I don't get confused when I go back and forth. So remember, your a value is the number in front of the x squared, so he's just a 1. The b is the number in front of your x, so 16. And then the c, of course, is the constant hanging on the end, so positive 59. All right, so here we go. Let's start throwing some numbers into the quadratic formula. All right, so here we go. X equals negative b. Well, b is 16, so negative b would be negative 16 plus or minus square root, all right, of b squared. Please notice I'm putting it in parentheses. Minus 4 times a times c, writing all that down in parentheses, all over 2 times a. All right, so this is step number 1, right? A's, B's, and C's plugged into the formula. Now, step number 2 is to grab your calculator and to type in all of this underneath the radical. Do not put the radical in your calculator. In fact, this is what I always like to do on step number 2. Before I grab my calculator, I actually like to just go ahead and bring everything down. I go ahead and do my 2 times 1 in the denominator. Obviously, I'm just going to write 2 now, right? But this is my template from step 1 to step 2. All I'm doing from step 1 to step 2 is typing all that mess in underneath the square root. Please use your parentheses. Type it in exactly as you see it and exactly as you would read it out loud. So I hope you guys are getting the same number I am. I am getting 20. All right, now it's at this point where you are going to analyze or ask yourself whether or not 20 is a perfect square. It is not. You can try it on your calculator. I'm just going to write that, not a perfect square. So if it's not a perfect square, that means you need to go off to the side and see if you can simplify the square root of 20, which of course we can. We've done a million times, right? So 2 times 10 or 4 times 5, it doesn't matter what you use. And then 2 times 5 will all end up with 2 2s and a 5. And remember, when you simplify radicals, we're looking for pairs of numbers. So whatever number I have a pair of, I get to take that number out. So the square root of 20 becomes 2 root 5. Now I'm going to bring everything else down, the plus or minus, the negative 16, all over 2. Now, technically, this is my answer, except at this point, you want to ask yourself, is it reducible? Reducible. Does that have an E in it? Is that even a word? Anyway, we're just going to use it. All right, at this point, you're going to ask yourself, is it reducible? And the only way this mess of a fraction can be reducible is if all 3 numbers that exist, I don't care about the radical. I can't touch numbers inside of radicals after they've been simplified. So I only care about the terms after that are outside the square root. So the only way this guy is reducible is if I can divide all 3 numbers by the same value, right? If I can't, then I'm done, right? But if I can, then I do need to reduce. And it does look like all these numbers have a 2 in common. So that means I can reduce this negative 16. He's going to turn into a negative 8. 2 goes into 2 once, and then 2 goes into 2 once. All right, so I'm going to rewrite now what I have. I have negative 8 plus or minus 1 root 5, which is just root 5. You can write the 1 if you want to. And then I don't need to put the denominator of 1 because it's understood to be there. So these are my answers, right? What I would like you to do, however, if you'll read the instructions, it says leave answers in both approximate and exact form. So here we go. I'm going to branch this off. Technically, one of my solutions is x equals negative 8 plus root 5, which is approximately, I don't know, I'm going to plug that in my calculator. Negative 8 plus root 5 is negative 5.7-ish. I'm just going to round to the nearest tenth. And then my other solution is negative 8 minus root 5, which is approximately something. Again, using my calculator, I'm getting negative 10.2. Again, these are rounded decimals because these decimals go on forever and ever and ever. If you want to write those as ordered pairs, we just had this conversation at the end of the last video, you are more than welcome to write those as ordered pairs. All right, I feel like I've already sucked up enough time doing this problem, so I'm not going to do that. Okay, but those are our 2 solutions. Now, you know what I'm going to do? I just did all this amazing algebra work doing the quadratic formula, and I would hate to miss my answer at the end. So I'm going to go to Desmos. I'm going to type in this function, x squared plus, oops, that's not plus 16x plus 59, because we moved it to the other side. Maneuver my graph just a scotch. Let me just go here. There we go. And I'm going to go tap on my solutions. Oh my goodness. What do you know, right? Negative 5.7. And that should be 8, I guess, if I round to the nearest tenth, sorry. And then negative 10.2. Ta-da! Awesome. I'm going to change this. Hold on really quick. I did not notice the 6. Sorry about that. You were probably like, what? So negative 5.8, actually. Sorry about that. Right, which totally confirms, again, on your test, I don't really care. I mean, I do care that you get the right answer, but I'm going to be checking all of this. And if all that work isn't shown, then you're not getting any credit for that problem. Okay? All righty. Here we go. Got 2 more of these just really quick. All right, looks like this one's already set up for us. Let's see, the A is 4, the B is 16, and the C is negative 65. All right, let's get after it. Here we go. X equals negative B, so negative 16, plus or minus square root of B squared minus 4AC. There we go. All over 2 times 4. There we go. All right, once you have your formula and your A's, B's, and C's, you're pretty much set. And then, of course, this is my step number 1. So step number 2, I'm going to go ahead and write my little template down for myself because I just want to remind myself that all I should be doing on the second step is simplifying that number under the radical. And of course, I'm going to go ahead and write 8 in the denominator since I can just do 2 times 4 really quick. All right, I'm going to go type in all that mess underneath the square root. Please make sure you use your parentheses. 16 squared minus 4 times negative 65. And I'm getting 1,296. Okay, so remember, let me come back to this one. At this point, you need to analyze whether or not that number under the square root is a perfect square or not. Right, so here we go. We've got 1296. I'm going to go ask my calculator, is that a perfect square? My calculator says yes. Right, so yay. He is a perfect square. Yay. Right, so if he's a perfect square, right, that means that we can just go ahead and let our calculator tell us that the square root of 1296 is 36. And I can just go ahead and simplify my square root with my calculator instead of having to do a factor tree. If you want to do a factor tree, you're more than welcome to. Everybody will have a buddy, so everyone will come out of the radical and you won't have a radical left. The biggest mistake I've seen from you guys this year is when you take the square root of a number, you keep the square root on the 36. And please do not do that, right? If it's a perfect square, you're actually taking the square root of 1296, and that is equal to 36. Like it's not equal to the square root of 36, it's just 36. So make sure you don't put that square root on there. All right, and because he's a perfect square, that means we're gonna be able to get some nice pretty answers out of this, right? So at this point, I'm gonna be able to split it, and I'm gonna do -16 plus 36 divided by 8. And then I'm gonna go do -16 minus 36 divided by 8. Please make sure you use the fraction mode on your calculator, or you do this as 2 separate steps. Please don't just type this in your calculator as like this, right? If you type it in your calculator like this, your calculator is going to do the division first and then add it to the -16, and that is not what we want it to do, okay? So be really careful. All right, so this one is going to give us x equals, okay, let's type it in, -16 plus 36 is 20, and then we divide that by 8, and I'm getting 2.5. All right, and then I'm going to do -16 minus 36, which is -52. I'm going to divide that by 8, and that gives me x equals -6.5. So when it's a perfect square, we get nice, friendly answers typically. And these are very friendly decimals, right? They're nice little 0.5s. Now, obviously, I'm not going to miss out on being able to check my work here. So you know it. We're going to go type this into Desmos really quick and just make sure that those are, in fact, the solutions, because there's so many ways to make a tiny little number mistake on these problems. And Desmos is going to help us check that to make sure we're not making a silly mistake. All right, so here we go. Oops. So here's my parabola for that. I'm going to go click on, -6.5, 2.5. Yay. All right, so we got those perfectly correct. All right, last one. Again, I would highly suggest like pausing the video when I'm doing these long problems. Pause the video, do it yourself, see if you can get it yourself, right? And then unpause the video and you can kind of see if you did everything correctly. Okay, just copying my work isn't going to help you out too much if you're not working at it yourself. All right, so number 16, looks like I have a constant on the left and on the right. So I need to subtract this 80 to the other side to get my function set equal to 0, which is going to give me -72. Now you'll notice because of that, I don't have a B term. So that means my B term is 0 and my C term is now -72. All right, and that's okay. You can have a B value of 0 and a C value of 0, right? You just can't have an A value of 0 because obviously then you wouldn't have a quadratic. We wouldn't have that x squared term, right? So it's not all unusual to have B or C values of 0. All right, now that I have my numbers, I'm going to throw them into my quadratic formula. X equals -b, which is 0. Technically, you can just cross that off. We don't even need that. Because if I plus or minus 0 from anything, it's just gone. Square root b squared, so 0 squared, minus 4 times 5 times -72. These are big numbers. All over 2 times 5. All right, so once again, I don't need to bring down that -0 or that -0. He's not gonna do anything to my problem. So I'm gonna go ahead and get my template going for myself like I've been doing on every problem. Because I'm gonna type all this in my calculator and figure out what -4 times 5 times -72 is. And I'm getting 1440. All right, now fingers crossed if you don't know your perfect squares, right? I'm just gonna type it in my calculator and be like, are you a perfect square? And he's not. I get an infinite decimal there, right? So, wah wah, right? Not a perfect square. All right, so if he's not a perfect square, that means we need to simplify him. So I'm going to go off to the side. I'm going to make my factor tree. I'll just do 10 and 144. And then 10 is 2 and 5. Now, obviously, you can shortcut this if you know what I'm talking about. If not, I'm just going to kind of do this the long way. I'll do 2 and 72. Again, I know 144 is a perfect square. So if you want to break that up into 12 and 12 and stop there, then that's fine with me. Right? I just don't want to lose anybody. So 2 and 36, 2 and 18, 2 and 9. So many factors for 1440, and 3 and 3. Oof. All right. So let's see, I ended up with 5 2s, 2 3s, and a 5. Okay, so let's see, what can we take out? I can take out a 2, another 2, and a 3. Okay, so remember when we simplify square roots, I'm going to go over here, plus or minus, I'm taking out a 2, and a 3. And I'm going to multiply all those together, right? Whatever comes out gets multiplied back together. So 2 times 2 is 4, 4 times 3 is 12. And then what doesn't have a buddy stays inside. Well, the 5 and the 2, those do not have buddies, so they get multiplied back together and they stay inside. And then we have our 10 denominator. All right, now is he reducible? Again, there's our question. Reducible, if I can spell. Question mark. And yes, he is. Now, I don't have a number over here anymore because it was just 0. So now I'm just looking to see if those two numbers are reducible. And yes, right, we can reduce by 2. So that's going to give us a 6, and that's going to give us a 5. So our exact answer, all simplified down as much as possible, is going to be plus or minus 6 root 10 over 5. Oof, I'm running out of room. Hold on. I'm going to move all this up here. There we go. Good enough. Okay. So let's see. Now I'm going to branch it off. So that means x equals positive 6 root 10 over 5. And x equals negative 6 root 10 over 5. And I am going to go type that in my calculator to get those approximations. Please use the fraction mode on your calculator. Right, hit your alpha y equals so that you get a little numerator denominator action. So 6 square root 10 and then divided by 5. I'm getting 3.8-ish. Again, that's a rounded to the nearest tenth. And then I'm going to type in negative 6 root 10 over 5. And what do you know? I'm getting negative 3.8. So that's the approximate. I, of course, would much, much rather just have the exact, but the directions in your review do tell you to round. And we just told you to round because we want you to check your answers in Desmos. But on your test, really, I just want the exact solutions, right? But we're just practicing the rounding part so we can check our answers in Desmos, okay? Which I'm going to do right now. So I'm going to go to Desmos. I'm going to type in my function, which was 5x squared minus 72. And I'm going to go tap on my solutions. And what do you know? Positive and negative 3.8. Yay. All right. So there you have it. Our lovely review on quadratic formula. All right. I'll see you in video 7.4.